Section 5, Video 2. We're going to focus on two of these equations out of order because these are very similar in nature. Then we'll get to the others. So our first one, if you remember, we are to take one equation and solve for one of the variables. But if we notice, one of them is already solved for a variable. So this is a very nice system of equations to start with. Now we're going to take what y is equal to, which is x minus 3, and we're going to substitute that into the other equation for y. That's our substitution part. And what we get out of that is 3x plus y is now x minus 3. We replaced it. We substituted that in for y equals 1. Now since there's, so basically we went from an equation with two variables to an equation with just one variable, both x's, which means we can solve this equation for x. There's just a plus sign outside the parentheses, so that does not change anything on the inside, so I can write or rewrite this problem without the parentheses. I have like terms, which gives me 4x, and we have minus 3 equals 1. I'll add 3, so here I'm just going to solve for the variable. Divide by 4, and x equals 1. Now again, remember, we are looking for an intersection point of the two equations. And that intersection point is an ordered pair. And we just found the x. So now we're going to take this, and we can plug it into either original equation. But we want to be strategic here and put it into an equation that is going to be easier for us to plug into. And in this case, that easier one would be the second one. It's already solved for y, so all we have to do is plug in 1 for x, and y is equal to a negative 2. So that negative 2 is the y value of our coordinate. So if we graph these lines, they would intersect at 1, negative 2. But it's not graphing, because graphing is approximate. This is an exact answer. Another one that looks similar to that here. We have one of the equations solved for a variable already. So we're going to take what y is equal to. We're going to plug that into the y of the second equation. And that will give us 4x minus 4. And now the y is replaced or substituted for what it's equal to. Again, we went from an equation with x and a y to an equation with just y. So I substituted in what y is equal to, and now I have a distribution that needs to occur, unlike the last one. And we get a plus 32x plus 44 equals 8. Combine like terms. We have 36x plus 44 equals 8. Subtract 44. We have 36x equals a negative 36. Divide by 36, and x equals 1. Pardon me, we're dividing by a positive 36 there. That's a positive. So it becomes negative 1. So we found the x value of the coordinate, negative 1. So again, we can plug it into either one of these equations, but the most efficient one is the first equation. So we go y equals negative 8 times negative 1 minus 11. And that will give us a positive 8 minus 11, which is a negative 3. And that is the coordinate where they would intersect. So at negative 1, negative 3 is where the two lines would intersect if we were to graph them. And this ends Section 5, Video 2.